Hi, in this lecture, we're going to cover the binomial distribution. So here's the outline. Binomial distribution, computing probabilities and percentiles related to binomial distribution. Formulas for mean and variance for a binomial distribution. So these are essential information about binomial distribution. So this talk is kind of like a binomial distribution 101. The binomial distribution is a probability distribution for a dichotomous variable, actually a dichotomous random variable. One of the best conceptual model for the binomial distribution is the number of heads in a finite number of coin flipping experiments. So just imagine you have a coin in the hand, you just flip it for a certain number of times and count how many times you see a head. And since we're online, we don't have the physical coin, but here are some really interesting websites where you can do some virtual coin flipping experiments. It is a lot of fun. Just try to go to each site and do some experiments online and see what it, feel what it's like. So more formally, if you want to define a binomial distribution, then we can make the statement like this. The number of successes in a series of independent random experiments with a dichotomous outcome, meaning success or failure, follows a binomial distribution. Okay. So the random variable is the number of successes in a series of independent random experiments with a dichotomous outcome. And on the right-hand side of the slide, you can see the notation x tilde. So tilde is like x follow. A binomial distribution, we use B and P. Okay. So there are 4 conditions for this binomial experiment. 1, there is a fixed number of n trials carried out. 2, the outcome of a given trial is either a success or failure. 3, the probability of success P remains constant from trial to trial. And 4, the trials are independent. The outcome of a trial is not affected by the outcome of any other trial. Okay, so these are the 4 conditions for a binomial experiment. Right? And in public health, if the outcome is disease versus no disease, then P is the prevalence of the disease in the population. Mathematically, we can use B and P for the notation of a binomial distribution. So we can say the random variable x follows a binomial distribution is denoted as x tilde B and P. Okay. And the probability for x, the formula for the probability of x is shown on the right-hand side. So basically, P of x equal to n factorial divided by n minus x factorial times x factorial, and times P to the power of x times Q to the power of n minus x. Okay. So, and the n is the total count of the experiment, and x is the number of successes, and P is the probability of success, and the Q is the probability of failure. Okay, and you can also watch the 2 videos linked here to learn more about the definition, the formal definition of the binomial distribution. And how to compute probability of the binomial distribution? Of course, the first one is just use the formula. Is as we have seen in the last slide. You can always use the formula to do hand calculation. And of course, it's more likely we're going to use technology more. You can use Excel or SPSS. Here are the 2 videos linked for examples of doing that. Okay. So the right-hand side showed a screenshot of if you use the Excel function binom dist, you can actually specify the number as and that's the number of success trials, that's the N. Probability S, that's the P. And cumulative, you should select true. Okay. So this would be the probability you're going to see at least 2 successes out of 50 trials with the success probability of 0.01. And for the percentiles of binomial distribution, we can use Excel's binorm inverse function. And here's also a linked video showing the steps of how to compute percentiles of binomial distribution. And we have examples as demonstration. So check out those demos, and I also will provide a video showing you how to do this step by step. For the binomial distribution, if you want to compute the mean and the variance of this binomial distribution, there's a shortcut. You don't have to use the definition of the mean and variance for a general PMF, probability mass function. So for a binomial distribution BMP, there are simple formulas for calculating its mean and variance. So here's a linked video again. But on the right-hand side, you can see the mean of the binomial distribution is simply n times p, and the variance, sigma square, is simply mp times 1 minus p. Okay. So sometimes if you want to calculate the mean and variance of a binomial distribution, as long as you know n and p, you can just use this formula in a very straightforward way. Thanks for watching.